Okay, here's my first attempt at creating a video lesson for computer programming in Scratch using my phone as a camera, video camera, because there's some math that I want to talk about. Normally you see my videos and I'm just showing you my computer screen and how to write the code and pull the blocks and what those do. But what we're going to talk about today, at least in this portion of our video for lesson 6, is it's doing some math. Because our big idea, what we really want to get around to, is writing a program that will return or give us the equation of a line given the two coordinates given the coordinates of 2 points on the line. Alright, so we have to understand some pretty good mathematics to be able to turn our computer program into something that's useful for us, not just a fun game, but something that will do some work for us. Alright, so the things that we'll need to know to be able to do this, if we want to write a program that will give us the equation of a line, a linear equation in slope-intercept form, what we want to know is we have to understand what does slope mean and what is a y-intercept. We've already discussed in class in lesson or activity 5 how to determine 2 points, or how to input 2 points on the line, just like you would be given on a quiz, okay, or on a test. It would give you 2 points on a line. So for example, let's just take a look at a coordinate plane here. Alright, let's say that I give you the point, here's our Cartesian plane. We have our y-axis, vertical axis, and our horizontal axis, the x-axis, and they're all marked off evenly this time. 1, 2, off in this direction, -1, -2, and so on, and this way as well, 1, 2, and -1, -2, and so on. Alright, and 0, 0, the origin right there in the middle. Now let's say that I'm using the point 3, 5, so over 3, up 5, 1, 2, 3, 4, 5. Here's a point on our line, and as I said, the coordinates are 3, the x coordinate is 3 over 3, and the y coordinate is 5, up 5. So 3, 5 is how we denote that. And let's say that we have another point, -2, -3. So -2 on our x and -3, 1, 2, 3 on the y. Now I'm not exactly sure where this is all going to lead. I just pulled those out of the air. I'm going to get a straight edge here and connect those points. All right. So this one was -2, -3. So let's connect those just so we can have an idea of our visual of our line. All right. So those 2 points define a line in the plane. There, no other line goes through those 2 points, or any line that does is the same line as this one. So the things that we said we needed to know were the slope. Now, slope is defined as how steep the line is. How steep is that? And the way we would talk about that, let's move this up. The way we would talk about and discuss and denote the slope of a line is, it's called slope is called the rise, which means to go up, over the run, which means to go forward or back, right? All right, and the way we would define that mathematically would be the change in the verticalness, the rise. Change is denoted by a little Greek letter called delta. So delta y, and we divide that by the change in x. All right, the change in the y direction versus over the change in the x, and that defines the slope. How far does it rise versus how far it runs? So let's just say here, so from this point to that point, we want to know how much does it change in the y direction. How far apart are the y coordinates, the -3 and the 5? So the way we do that is that we take the first point and we take away, so it's the first, well actually the way they define it is the second y coordinate take away the first y coordinate. All right, y sub 2 take away y sub 1. That's what the change in the y direction is. All right, so we could actually kind of map that out here. It's going to be, so from here to here, the change in the y is 1, 2, 3, 4, 5, 6, 7 is 8, right? All right, but the reason that we can get that is because we take the first coordinate, -3, or I'm sorry, the first one, which was, or the second one, that was right, was this one. It doesn't really matter, we're going to get the same answer either way, but we're going to get -3 is our y coordinate, our first y coordinate, minus 5, our second y coordinate. All right, and -3 minus 5, or plus a -5, is a -8. So the change is -8. So from here to here it goes down 8. And then we take the change in x. So the second x coordinate minus the first x coordinate. X sub 2 minus x sub 1. This is all, just mathematical musings and thinkings, and this is just the technical way that we do this. So the second x coordinate was -2. Take away the first x coordinate, which was 3. All right, and so what we're determining here is how far apart xy's are they. If we were to just compact everything down, how far apart are those 2 points on the x-axis? All right, and we could see 1, 2, 3, 4. It's going to be 5. They're 5 apart. So a -2 minus 3, or plus a -3, is the way we think of that, is a -5. And so from here to there, it goes backwards -5. All right, so it goes down 8 and backwards 5 to get from one to the next. All right, that's what our slope is. So the slope, in this case, the slope of our equation, and we show that a lot of times with the letter m, and not a lot of times, we do, with the letter m. So the slope is equal to all of this work, which is -8 over -5. All right, and since these are both, we can do some quick figuring. The -8 over -5 is actually just plain old 8 over 5, and it can't be reduced. 5's a prime that doesn't go into 8. So our slope is 8/5. So over 5 up 8. Over 5 up 8 would get us another point on the line. From any point on this line, so for example, here, if I were to just pick any point, if I were to go down 8 and backwards 5, it would get me on that line again. All right, that's how steep, we've defined how steep it is. All right, that is what we want to figure out. For any line, any two coordinates that we are given, how can we figure out the slope. That's what we're going to do. We're going to write a program at this point that will define the slope, that will find the slope. If we have input 2 points, like we have, right, you've already written the program that will input the 2 points in a list. What we want to do now is learn about creating variables and then programming our computer, writing the code to do the mathematics for us, to actually take the y coordinates and subtract them, and the x coordinates and subtract them, and then divide them. So we'll actually get a decimal number when this is worked out with our in our code. We could get a decimal number, or we can just tell it to print out whatever this is. So we could get have an output that says slope equals, and we'll just say it will give us the y minus y and have a -8 over -5. That's a valid answer. It's not reduced, but it's a true and valid answer. So let's move to the computer and let's write some code that's going to help us find the slope. The next step in writing some code that will be able to return the equation of our line. Okay? So let's move over. Okay, so let's jump into the programming portion of our assignment, our activity. What we're going to be doing today is creating lists and variables and creating routines and subroutines and using these blocks. We're going to be making a block so that we can create a subroutine that will find the slope of our line. And we'll be using the list and making some variables and using the operators blocks in the green. You know, this the operations blocks, the operators. So where was I? Here we are. So what I expect for you to do, and you'll know you've done a good job when you create and save your Scratch project that shows your sprite, and it's going to be building on the code from activity 5. But I want your sprite to explain in your own words how to find the slope with the coordinates that were given, and I want it to do the mathematics to find the slope and then report the slope of the line defined by the 2 coordinates. All right. I also want you to, after you submit it, to justify your grade your work, and then justify it with phrases in the rubric. All right. Don't forget to save your, use the file naming protocol where you have Scratch. It'll be scratch6, and then your first initial and your last name. All right. So remember, we're going for eventually writing code that will write and report the equation of a line in slope-intercept form, given 2 coordinate points on a line. Alright, so remember, you can watch this video as many times as you need to, and I'll try to be as clear as I can and show you what I'm doing and thinking. So let's go ahead and get started. Let's move over to the Scratch app. Alright, now this is my Scratch 5 project. I've already defined my block, my subroutine to get the coordinates. Alright, so just to refresh your memory, I created lists so that one called X coordinates and one called Y coordinates. And it's going to just gather the information. I'm going to feed it some points. So let's say we've got 2 for our X coordinate, 3 for our Y, and then another point. Let's go backwards into the third quadrant, and let's say a negative 2 and a negative 3, just to see what happens. So one point is 2, 3, 2 comma 3, and another one is negative 2, negative 3. All right, and that's all our first, our scratch5 program was supposed to do, is write that subroutine. So I've added some documentation here. It tells me this is my main code, all right, and this is going to call all my subroutines. And I've created one subroutine over here called getCoordinates. And this one gathers the x and y coordinates for 2 points on a line and places them in a list. Or place them in a list. It displays the coordinates as a table. All right. Let's close that. So now that we get this information, let's go ahead and use it to find the slope. Remember, we talked about slope a few minutes ago as being defined as a change in the y values and a change in over the change in the x values. So let's think. What do we want our character to do? We want it to find the slope and explain to us. So let's create a subroutine. Let's make a block, and let's just call it finding slope. Finding slope. Okay, slope is just the steepness, mathematically defined steepness of a line. All right, so let's start defining that now. We want to use these. Remember, it was x or y sub 2 minus y sub 1. So it's really negative 3 minus 3 in this particular case. So let's have our character say, now we will compute. Let's use some fancy words here. Compute the slope of this line. We'll make it say that for 3 seconds just so that everyone can read it. Alright, and I want it to tell us, let's make him think. The slope is defined as the change in y values over the change in x values. What does that mean? Okay. Well, let's just run that. Now we will compute the slope of this line. The slope is defined as the change in y values over the change in x values. I need that to stay up a little longer. Oops. Let's make that 5 seconds. The slope is defined as the change in y values over the change in x values. That means, so now I want him to say, let us determine the change in y, or verticalness. Let me pause. Okay, so it's change in the verticalness, or the rise. Let's say that the change in y, or the rise. How much does what's the y distance between the 2 points? Let us determine the change in y, or the rise. Let me pause. Okay, so I'm going to change so that that'll display for about 4 seconds. So let me just double check. So now we'll compute the slope of the line. The slope is defined as the change in y values over the change in x values. Let us determine the change in y, or the rise. Alright, so we want to do some mathematics now. Alright, we want to take the coordinates that are in our list here that we have gathered, the data that we've gathered, and let's create some variables here. Alright, and remember, we call our variables, there's x sub 1 and x sub 2 and y sub 1 and y sub 2, or the first y value and the second y value, and so on. So I'm going to create a variable, and I'm going to call it x1. I'm going to use a capital X, x1, x sub 1. Alright, and so I want to set x sub 1 to, let me find it here, item 1, there we go, the first item in the x coordinate list. Alright, now let's create another variable. Let's call it x sub 2, or x2. Alright, and let's set x sub 2 to the second item, or I guess we could say it to the last item, since there's only two, of the x coordinates. Alright, so we've got x sub 1 and x sub 2, and we're going to write the code that's going to do all the mathematics for us. It's going to do all the heavy lifting. Alright, let's create a variable for the y's, the y values. So let's call it y sub 1. And let's set y sub 1 to the item number 1 of the y coordinate list, so that the first coordinate, x sub 1 and y sub 1, go together. And then let's create another variable that we're going to call y2, y sub 2, and we're going to set that variable equal to the last item, the second item of the y coordinates. Alright, so our first subroutine gathered the information and put it in the list. Now our finding the slope routine is going to take them from the list and to put them into defined variables. And now we're going to do the computations necessary to find the slope. So let's do some figuring. So it says, let us determine the change in y, or the rise. Alright, now remember, the rise is the change in the y variables, or the y coordinates. So let's create another variable. I guess we need to do that to determine the numerator of our slope. So I'm going to call it the change in y, or delta. I don't guess I can put a little triangle. Delta y, or change in y. How shall we define that? Change. Change y. Y change. Change in y. Change in y. Okay. So I've got one called change in y. Let's make another one called change in x. Alright. And now, what I want to do is, I guess I want him to explain. So, let's see here. Now, what we're going to do is we're going to explain how this works, but then it will do it for us every time. So if we understand how our program works, how our code works, and we're able to explain it, then then the program will do the heavy lifting for us from then on. All right, we can put in any 2 points, and it will actually reinforce our learning. We'll understand the mathematics behind linear equations much more effectively as we're more deeply as we look at our program. So let's have our character say that first we need to subtract the second y value. Maybe we should just say this. First we need to subtract y sub 1 minus y sub 2. And he'll say that, and then we'll have him explain that. Y sub 2. Let's have him say that for 4 seconds. And he'll say, or in other words, I want him to say, let's move this out of the way. It's getting kind of in the way. All right, so he'll say, or in other words, now I want him to say, let's get some joins out here, see how many we need. He's going to say that y sub 1, so it's going to say whatever we have put in for the first y values, so it'll report out 3 space minus, oops, I guess I better put in a join here, space minus, and put in another join, minus, and I'm going to put in y sub 2. I better get some more joins here to make sure I've got all these. So it's going to say y sub 1, or 3, minus, and it's going to say negative 3. Then I want to say space equals, oops, I always remember this. For me, this is the hardest part, is remembering to put in the correct number of join the words so that I can have all the correct output. So it's going to say join is actually going to say 3 minus negative 3 equals, now we have to compute that. Let's just have him figure that out. Oh, we have variables for that. That's great. So let's set change in y. Let's do that one first. Set change in y to equal, let's just do the computing here, to y sub 1 minus y sub 2. For crying out loud. Y sub 1 minus y sub 2. Now I'm going to put that in here. Alright, you see what I've done here? And we're going to put change in y here. So here's how it's going to report. I'm going to throw this in here, and let's have it report that for 5 seconds. And let's see what happens. I think the bell's about to ring. Now we will compute the slope of this line. The slope is defined as the change in y values over the change in x values. Let us determine the change in y, or the rise. First, we need to subtract y sub 1 minus y sub 2, or, in other words, 3 minus a negative 3. That equals 6. So, we now know that the change in y our numerator is going to be 6. Alright? Well, I will be back to record more in a little bit. Okay. Well, what I would like for you to do at this point is to finish this subroutine with a neighbor. Talk with someone that you feel that you can work with, and get together and make a plan. How would you continue to finish this and find the slope and have our sprite report to us the slope? Tell us the slope of the line that we were talking about, that you input the coordinates for. Any line. Alright, now we've already established and defined the variables, and we've talked about how to find the change in y, okay, and established that and reported that. What else do we need to do to find the slope? Talk about that with your table partner or your group, and make a plan and complete this finding slope subroutine so that we can continue on. Remember, all you want it to do is report the slope. You want it to tell us what the change in y is. It'll also need to find the change in x and report that back as a slope. Alright, change in x over change in y. Alright, so have fun with that. Don't stress too much, but think about the mathematics behind it. And if you need some paper or pencil, let me know. And well, good luck. Let me know how you're doing.